Hello and welcome to the next video in this series as together we learn Prolog. Today we're going to be spending a fair bit of time going over what we've already learned, some of the concepts like unification, but using them in a slightly more interesting way. The idea is to really embed and practice those concepts because they are really important. We will introduce one new thing today, which is the idea of lists. So we'll do that in the second half of this video. But the first half we'll practice the idea of matching or unification and see how it can be it can be used in quite an interesting way. And what we're going to do today is to generate simple English sentences. Now, before we get too excited, that doesn't mean we're going to be generating content like ChatGPT or some of the best AI systems out there. We're going to keep our system very simple but still quite effective, just to show the power of unification. So we'll keep ourselves limited to a very simple idea of what an English sentence is. So on the screen here you can see that I've got 3 sentences, very simple. Of course, English sentences can be more complicated, can be more sophisticated, can be richer, but we're going to stick to just this type of simple sentence. So we've got John eats apples. And the next sentence is Mary picks fruit. The next one is Zoe reads books. We could try another one. We could say Sophie, let's think of something, bites bananas. That'll do for now, bananas. And the thing to spot here about these simple sentences is they follow a structure that is like a template or a blueprint. They all start off with a person, then a verb, and then an object. So there is a pattern here which is person plus verb plus object, and that's a nice scheme for testing whether a sentence matches or conforms to this kind of scheme to be a sentence. So we'll keep things simple and imagine that just for our purposes this is what a sentence looks like. So if something doesn't conform to that, we'll say that it's not an English sentence. So we can use this rule, this scheme, this schema to test whether a sentence conforms, and later we'll see how we can use it to generate sentences as well. So this is just showing what we've just talked about, that schema. So John eats apples is a very simple sentence, and the schema it conforms to is subject, verb, object. You may be familiar with those words from grammar, but if you're not, hopefully it's obvious enough that there's a person, the thing that they're doing, a verb, and who they're doing it to, the object. So let's look at our sample example program, which is number 5 in our series. We start off with what should be quite familiar. We've got properties and we've got things. So the first two, we can see that there are things called John and Jane, and they have a property called subject. The next two facts in Prolog's database mention a thing called eats and washes, and they have a property called verb. And finally, apples and spinach, they have a property called object. So this is what we've done right from the very first video, the idea of creating facts which mention a property about a thing, and we can just, as a practice, we can test. So we can say, is John, is it a subject? Subject. So we're asking, is John a subject? And the answer is true. And we can ask, is eats a verb? Does the thing eats have the property verb? And the answer is true. And we can do that again for the last one. Let's say spinach, for example. Spinach. Spinach. Is that an object? And we should get true. So that's a way of defining the parts of speech or the parts of a sentence. John and Jane are subjects, eats and washes are verbs, and apples and spinach are objects. So that's simple enough. We've done that before, so nothing should be new there. Previously, we've also talked about satisfying a property or multiple properties. I think it might have been the last video or the one before. I have to go back and check. What we can see here is we've created a relation, remember relations, which link one property to another or multiple properties. And here we've got three properties, not one, not two, but three. And you'll remember the comma means and. So this is true, sentence is true if this part of this rule, the first kind of goal, is true, and this is true, and this is true. And what this rule is saying is what we've just talked about, that a sentence is well formed from these parts X, Y, Z if the first one, the first thing, X, is a subject, as in the property of X is subject, and that's true, and, that's the comma, Y has the property verb, and the property Z has, the thing Z has an object, it has a property object. So that's putting into Prolog what we've just talked about, simple English sentences. Subject, verb and object form a simple sentence. Now this might look new to you, this kind of XYZ, three things inside the bracket. If you're used to other programming languages, that won't surprise you. It's just providing more information to a property or a function. You'll have seen that elsewhere. And it's the same thing here. We're providing more than one item of information to sentence. So for sentence to be true about X, Y, and Z, X must be a subject, Y must be a verb, and Z must be an object. So hopefully that's intuitive, or kind of not too strange. It should be fairly straightforward. So let's see that in action. That's probably the best way to kind of bring it to life. So we've just tested each of these individual things. Let's test them together. So let's try ourselves writing a query which tests two of those things. So we're saying subject John. So is John a subject, and is eats a verb? And that's true. Oh, that's false. What have I done wrong there? Oh, verb is not a verb. Eats is a verb. And that's actually a good counterexample to spot when things fail and understand why they fail. So the verb is not a verb. whereas eats is a verb. And we can extend that here to say, is apples an object? Apples. So this is a query which is asking, are all three of these things true at the same time? Is John a subject? Is eats a verb? Is apples an object? And rather than testing all three at the same time, this rule combines that test into this property called sentence. So we can say sentence x, y, z, and we're going to ask if John, as the first, they're called parameters, bits of information that are passed to it. John eats apples. Is that a sentence? So let's run that, and it's true. Let's pause there and just go over what's happened there. So sentence, John eats apples. In order to answer this query, Prolog has to, well, it doesn't know whether it's true yet, so it needs to use the information in the database, the facts and rules. It has to use that to work out whether this is true. In terms of the very simple facts at the start, none of them are sufficient to answer whether sentence John eats apples is true. But this rule here, this one, that seems to be relevant. And the way, as you remember from the previous video, the way it knows it's relevant is if the head of the rule matches a query. So sentence John eats apples, sentence XYZ, that matches, that unifies. Do you remember unification? So this is true if the body is true. The head is true if the body is true. And so the Prolog's next task is to test each part of the body, each of these goals. Subject X, and X here is John, which is true. Verb Y, what's Y? Eats. There you go, that's true. And object Z, Z is apples. Object Z, apples is true. So that works. Let's draw a picture just to kind of run over that. If you get it, fine, just kind of skip forward a little bit. If you're struggling, I'll kind of draw that out in terms of writing, just to have a second go at it. So I'll copy that. Right, so I've written down or copied over those facts and this rule. And our query was sentence John eats apples. So this is the query. And to test this, to test whether it's true, Prolog needs to, well, it hasn't got anything else, it needs to look through its database of facts and rules to see if they can help prove this is true. Well, the rules on their own don't help because they're about subject, verb and object, and this is about a property called sentence. The rule here does match because it's got sentence and three parameters X, Y, Z, and this is of that form. The property is sentence, which matches, and there are three parameters, 1, 2, 3. By the way, the number of parameters is called arity, and you'll see that in the textbooks. So this subject has an arity of 1, and that's sometimes written as subject /1, and verb /1, and object /1. It says that object is a property which takes one parameter, one bit of information. Verb eats, verb washes, one information. So verb/1, and sentence is sentence/3. So sentence has a narrative of 3. It takes 3 bits of information. Any more or any less would not mean there's a match. Right, so this matches this rule, and in order to prove the head of the rule, we need to prove the body, because remember, the head is true if the body is true. It's that way around. And now the body has got 3 parts. It's got subject, verb and object, 3 goals, and they are actually filled in. So X is actually John, Y is eats, and Z is apples. Why is that? Because sentence XYZ matches this, and therefore the variables match. So the property matches this property, and those parameters, their variables, will match these things, John eats apple. And therefore, to prove this, subject, that's the first goal, subject John, that's easy enough because that's there. The next goal is, and remember it moves left to right, that's from last time. Subject, oh no, it's not subject next, it's verb eats, and that matches that one, so that's correct. And the third goal is object apples, and that matches that one there, so that's true. So all of these are proven to be true, therefore sentence John eats apples is true, and that's why Prolog can say that's true. If these things were not, if these goals couldn't be proven, then the sentence is not well formed. Let's try that. So if I say John wibble apples, that should say false, and the reason it's false is because yes, John is a subject and apples is an object, but wibble is not a verb. It's not in here. And even if we do put another verb like runs or swims, we know that's a verb, but Prolog doesn't because it's not in here. We could add it. We could say verb swims, and then it would say correct. Great. So this is a way of testing whether a sentence made of 3 words like Jane and washes spinach, whether that's a well-formed sentence. True, that works. So this is what we've done here, is we've used the schema for a very simple sentence to test whether this is a well-formed sentence, and we found some examples where it's not. If I put these things out of order, like spinach and washes, that should also fail. That will fail, because although Jane is a subject, spinach is not a verb, and object, and washes is not an object. It has to be in that order. So that's cool, but we can do more, and this is one of the kind of benefits of Prolog programming, is that if you define the scenario, the universe, the problem sufficiently well, then not only can you test whether things are true, you can use that same definition to create examples of things that can be true. You can generate content. So let's try that. So let's say, remember when we have variables in the query, we're asking Prolog which values for those variables make the query statement true. Do you remember we did that before? Again, if you need a bit of revision, just do go back and watch that video again or read the blog. So when we put a variable in a query, and remember variables have capital letters at the start, when we put variables in the query, we're asking Prolog, find ways to make this true. Which values for X, which values for Y, and which values for Z make it true. Let's start actually simple. Let's say washes and spinach, and we'll only have one variable just to start with. So we're asking which X would make these three words into a valid sentence. Let's run that. Well, it's saying that X equals John would work, so John washes spinach, that works. And Jane washes spinach, that works. And then there's no more. And again, do watch the previous videos to see how Prolog works through the list of facts and unifies them with the definition to find values that work. So here, washes and spinach are already defined, but X isn't. So subject X, that's unified with this first fact to give us John, and this second fact to give us Jane. So that's easy, that's nice. And in fact we can extend it, X, Y, Z, and run those, and it should give us, well, let's let it run through all the possible combinations. Oh, there's quite a few there. So John eats apples, John eats spinach, John washes apples, John washes spinach, Jane eats apples, Jane eats spinach, Jane washes apples, Jane washes spinach. So all the combinations of those words that form a proper sentence, it's found all of them. So that's quite nice, isn't it? So what let's take a pause here. What we've done is we have defined what a simple sentence should be structured like, and we've allowed Prolog to find examples that match that satisfy that definition. What we've not done is written a program like we might in C or Python or JavaScript, which in minuscule steps constructs a sentence. We haven't done that. We haven't said join John with, find the list of subjects and pick out one, and then find the list of verbs and pick out another word, and find a list of objects and pick out another word and join them together to make a sentence. And this is important because it's a different way of programming. It's a different way of thinking as well. It's called declarative programming, where we define what the problem is, what the structure of the problem is, and allow Prolog to find answers. So we define the what, not the how, and that's called declarative programming. And that makes sense because Prolog is about logic programming. We're using logical definitions, facts and relations, to define the structure of a scenario. It would defeat the point of Prolog if we wrote minuscule procedural steps to build sentences. So just with a list of vocabulary and one rule, we've generated what is 8 sentences, and that's all the right combinations there. Just a small point on style. XYZ is fine, but it can be more informative and easier to read if we use better words like subject. Remember, we have to have a capital letter at the start to tell Prolog that's a variable, verb, and object. And if we now run that, you can see that the replies are much more readable. Fantastic. So that's a really important point. In fact, it's so important I'm going to write it. So declarative versus procedural. And these are two different ways of programming or thinking about how to solve a problem. And declarative programming is about defining the structure of a problem or scenario or the thing that we're interested in. It's about the what. I should use better colours than that, shouldn't I? The what, not the how. So with normal traditional programming with C, Python, JavaScript, we write instructions that are carried out one after another, and these instructions are generally doing very small things, and together in small steps they build a solution, and we are the ones building that solution by writing those minuscule instructions. With declarative programming, we actually define the structure of the problem, the constraints, what's related to what the ground facts are, and then we let Prolog or any other language that's declarative find the solutions within the constraints of that structure. And it's much more powerful. It can result in very elegant programs, but it does require a lot more thinking, but that's okay. Part of learning Prolog is to be able to do that and practice doing that, and we will do that. In fact, every example now, every video, we'll be practicing this way of thinking. Now, I should say that Prolog it had an ambition to be, purely logical and purely declarative, but the reality is that it's not quite. It's some imperfections with that purist idea. So there are elements of procedural thinking involved, and we'll get to that later. But as long as we understand that and can manage it and know when that affects us, we'll be fine. But this is a great way of learning about declarative programming. Just before we do move on, I just wanted to highlight an aspect of how Prolog finds solutions to these kinds of queries with lots of variables to be filled in. If you look at the code we ran, you'll notice there's a pattern. So first the subject is John, 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 and in the second half of the answers the subject is Jane, 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 Jane. In the first half again, the verb is eats, eats, and then it moves on to washes and washes. So there's a pattern there. So let's see why there's a pattern there. And the reason there's a pattern is that when Prolog works through queries like this, as we've said before, it works left to right, and in this case it needs to find values to fill in. And the way it does this is it starts with the first goal and finds a value for x, and in our case the first thing in the rules is John, then Jane. So x equals John is the first thing it finds, then it moves right to verb, and the first one it finds that satisfies verb y is eats. So y equals eats, and then it moves right to z equals, and the first one it finds is apples, apples. So it's moved left to right and found values for x, y and z. What happens next is that it backtracks. Remember, we've come across backtracking before, where it unsets a variable to become empty again and then tries to find more potential values that could work. And it does it chronologically in reverse order. So the last thing it found was this. So this is the one that it then unsets, z equals question mark, and then finds another solution. So it's done apples, the next one is spinach. So z equals spinach. That's the next one. And we can see that in the first two. So first it's John eats apples, then John eats spinach. So the only thing that's changed is apples to spinach. It's the object. It's this part. Now it's exhausted those, then it'll go back to y, and after eats it washes, y equals washes, and then it will try all the combinations again of z for, so washes apples and washes spinach. Let's see that in action. There you go. John washes apples, John washes spinach. And then when it's done those combinations, it'll go back to unset the very first thing it set, x equals John to x equals Jane, and then run through all those combinations again. So that's called chronological backtracking. It's useful to know. It's not, I don't think it really impacts us very much, the order in which it does that, but it's useful to know that that's what's happening. I can't think of a scenario where that really matters, because an answer is an answer, it's either valid or it's not. But that's kind of useful to just have an insight into how Prolog works. Now, the last thing we're going to introduce today is a new thing, lists. And what's going to motivate us is that we're looking at these answers that Prolog's given us, and honestly they're not that easy to read. If this is supposed to be a sentence, Jane washes apples, and we can see subject is Jane, verb is washes, object is apples. It's even in the wrong order. It should be subject, verb, object. So what can we do about that? So let's introduce the idea of lists. So most popular languages will have a built-in method of collecting together, keeping together a set of, or a collection of things, and most will have this concept of lists. So let's start writing some things. Might have apples, might have oranges, might have banana. These are three things. To make a list out of them, we put them in square brackets. So different languages will have a different way of doing that. In Prolog, it's square brackets. So this immediately tells Prolog that this is one list, and it consists of three things: apples, oranges, banana. And the thing about lists is that if we have three things here, if I change the order A, C, B, that's not the same. And if I repeat things like A, B, C, that is also not the same. So the order and the repetition matters. There are other structures in other languages where that might not matter, but for Prolog, these lists, they're all lists, but they're different, and that's useful for us to know. So let's see if we can turn those words, the subject, verb, object, into a list, which will be much easier to read. What do I mean by that? So if I had John eats apples, if I had those as three things in a list, say L equals, list equals, that might be easier to read. So how would I do that? Well, we can imagine that a list has three things in it. We can say X, Y, Z, and if we unify these with something that confirms that they are a subject, verb and object, then we fill them in. So we can say a sentence consisting of one, where the input parameter is one list, XYZ, is true, that's that symbol, true, if sentence X, Y, Z is true. Or another way of saying it is if X is a subject, X, Y is a verb, and Z is an object, just like we did before. So if this is true, if X is a subject, Y is a verb, and Z is an object, then sentence is true where this thing, this list consists of X, Y, Z. Let's see that in action, because that will bring it to life. And in fact, you can see in the example program, we have that listed here. In fact, what we've written here is sentence now has an arity of 1. So this is sentence /3, has an arity of 3. This new definition, sentence with S, just one sentence, has an arity of 1. And the two are seen as different. So in Prolog, we have a property, these two have the same property, and they don't clash because they have a different arity. Again, if you're familiar with other programming languages, that might be something you've seen before. So as far as Prolog is concerned, this definition and this definition are different because the arity, the number of parameters, is different. So let's read what this is saying. The familiar thing, let's start with the familiar thing. This is exactly the same as what we had before. X is a subject, Y is a verb, Z is an object. Those things have to be true. But what also has to be true is that S is a list. So S is open bracket, close bracket, consisting of 3 things, X, Y, Z. And X is a subject, Y is a verb, and Z is an object. All of these things have to be true at the same time. And if they are all true, then S is a well-formed sentence where S is a list. Let's try that. Let's create a sentence. So, John eats apples. So this is our list, just that. And we're passing that list. Remember, as putting things in square brackets creates a list which becomes one object. It's a compound object consisting of 3 things inside it, but it can be treated as one object. So that's what we're passing, and this, because it's one thing, it will trigger or match this definition. It won't match this definition anymore because there are not 3 things between the round brackets. So this is a list, S, and inside it are 3 things, X, Y, and Z, and they have to be subject, verb, object. Let's run that, and it's saying that's true. So that hasn't brought us much from, what we were doing before, but the power, well, you might find it easier to write sentences like this, but the real power comes when we ask Prolog to generate. Remember what we said at the start? If we write our definitions well, then rather than just testing whether something is true or false, Prolog can actually generate things which match the definition, generate content, and that's quite powerful. So let's run this. This is exciting, actually. Will it generate S, which are lists, which are well-formed sentences? That's the hope. Let's go. Yep, S equals John eats apples. That's a list of 3 things, a subject, a verb and an object. So that's nice. That's much easier to read than what we had up here. Let's go next. John eats spinach. John washes apples. John washes spinach. And all of them. So there's 8 there. So that's much easier to read. Fantastic. I mean, if you really wanted to print out sentences without the commas and the square brackets, we can find ways to do that. But that takes us away from learning the key concepts about Prolog, like lists and unification. So that's fantastic. And if we just add another verb, so eats, washes, chops as a verb, then if we run this, we should get more combinations. There you go. So we've got combinations with chops. So John chops apples, John chops spinach, Jane washes apples. Now, just before we finish, we can use this in a interesting way. We can ask a different kind of question. We can say, who eats spinach? And then Prolog will find a value for x, or multiple values for x, which satisfies that. So we can ask questions. Let's run that. So John and Jane eat spinach. So that's interesting, just a different way of posing a question. We could say, what does Jane wash? Jane washes something. What does she wash? Jane washes apples and Jane washes spinach. So we can query our database of truth in a way that's a little bit more natural. It's not quite kind of Google levels of AI, but you can see that this is much more natural in terms of posing questions, and actually more sophisticated systems were built like this, for processing natural language. In fact, that was one of the early uses of Prolog, was to do natural language analysis and processing and working with natural language. It's quite well suited to it. We won't go into that in this course, but once you've done this course, you'll be really well suited to a solid foundation in order to kind of explore that yourselves. Fantastic. So we've done some new things here. We've practiced our ideas of unification. We've stretched ourselves a little bit with definitions with not just 1 or 2 parts, but 3 parts like this. And we've introduced the idea of lists, and we'll be using those again in future, because working with more than one thing at a time, it requires a collection of some sort, and lists is a very common way of doing that. So we'll see those again. Fantastic, brilliant, that was excellent. See you next time. Bye.